Okay. This is I've driven my pickup upon this lightweight arch. I'm demonstrating the strength of this arch with I drive my truck on it. It's 1/2-inch plywood, top and bottom, with 5 inches of 4.5 inches of foam in the middle. I'll drive it on all over. Just to demonstrate the weight. The demonstration of the strength of this lightweight arch. As you can see, it's foam and just plywood, but you'll also see that there are holes in it. This is one where I used to put an axle in it to move it around. But conduits can be put through it to lighten the structure. It's been driven over, well, you can see the tracks on it 5 or 6 times. It holds up fine. It does deflect, but we're talking 1/2-inch plywood here, and that's it's not very much. There's 3/4 inch, 1/4 inch cables stretched the length and tightened against this aluminum plate that's mounted on the ends. What that does is it transfers it takes that internal force that flows down and goes to that, and then it goes into since forces tend to travel on the surface of an object in physics, then that's what this is based upon. Now, you could imagine this if it were corrugated steel. This is an 8-foot span. It could be 50 feet wide. So you could have a piece here that would be 50 feet across and 8-foot arch, and it'd all be the same strength. So it could be made in panels and used to replace concrete floors in these buildings that pancake down and kill everybody, because concrete is a fragile material. Once it breaks loose, its weight is 150 pounds per cubic foot. This structure, if used, would probably be somewhere of about half the weight, even if it were made out of steel. And the foam, I would not use this type of foam. I would use recycled plastic, and I would aerate it, and also put voids through it, as in these pipes, so that you could pass any of your power lines or water lines or anything you would need through it. There's a myriad of things that can be done with this. That's to replace reinforced concrete. Now, they're pre-stressed concrete. Larger units could be made thicker, heavier corrugated steel could be used, and in doing that, you could make a structure that could support, heavy traffic. It'd be thicker, it'd be much thicker and denser material used, and you would enclose the sides so that you wouldn't have any cavitation by critters or the sunlight breaking down the plastics that I would use in the middle. This is a patent that I've got, and I'm offering it to whatever company wants. I would prefer an American company get it and then sell it worldwide, instead of us having to pay the people of the United States having to pay another country for it. But I'm going to sell this and sell the patent, and it's a repairable, lightweight arch. If this were to get a void in it, you could inject foam into it and bolt down another panel of steel over the top and keep going with it. It could fall off a footing in an earthquake. It could be jacked back in place and reused. You never can do that with pre-stressed concrete, and you can't do it with reinforced concrete. Once they're cracked, once they're moved, they're done. It's over. You've got to tear it out and start all over. And you can imagine this if it were in a building and there were a huge earthquake that would break the panels loose, they would stay as a panel, as a unit, and it would fall as if it did break loose enough to fall, it would come down in Jenga type of sticks type operation, where there would be escapable holes, not like the pancake of the reinforced concrete floors that just pancake down and kill everybody inside. There'd be escape holes, and it'd be light. It would reduce the weight of a building on its footprint on the ground by probably a third. I would say, I'm estimating it probably, because concrete floors in a building are extremely heavy. Like I say, it's 150 pounds per cubic foot.